UPS Flight 2976. The catastrophic UPS Flight 2976 crash on November 4th, 2025 at Louisville Muhammad Ali International Airport reignited urgent questions about cargo fleet safety after the aircraft's left engine separated mid-takeoff. Witnesses and data show the engine detached, leaving the aircraft briefly airborne before it descended and struck buildings, killing 9 and injuring 15. The jet, loaded with around 38,000 gallons of jet fuel, took off from runway 17R at about 5:15 p.m. and reached only about 175 feet of altitude before it lost control. The separated engine was found lying in the grass near the runway, a stark visual echo of the tragic American Airlines Flight 191 disaster in 1979. At about 34 years old with nearly 62,000 flight hours, the aircraft, registration N259UP, belonged to an aging cargo fleet under heavy scrutiny. The crash shed light on the heightened risks: engine pylon fatigue, complex maintenance procedures, and structural weaknesses that can turn a single failure into a cascading catastrophe. Historically, the DC-10 MD-11 family had known vulnerabilities. The 1979 Flight 191 event resulted from a pylon failure that severed vital hydraulic lines and led to loss of control. Analysts now highlight similarities in the Louisville incident: structural detachment, followed by system collapses and loss of control. Cargo operators like UPS and FedEx continue to fly tri-engine wide-bodies beyond 3 decades of service. These aircraft endure heavier use, less visibility, and challenging logistics compared with passenger jets. The Louisville crash underscores that even proven designs require relentless vigilance, advanced inspection regimes, and proactive maintenance. Regulators and operators alike must reckon with this stark reminder: fatigue is inevitable, but failure is optional. As investigators dig into the maintenance logs, fasteners, and structural integrity of the engine pylon, one thing is clear: this incident demands swift action to prevent the next tragedy. UPS Flight 1307. It was February 7, 2006, just before midnight when UPS Flight 1307, a McDonnell Douglas DC-871F N748UP, touched down at Philadelphia International Airport after a routine cargo run from Atlanta turned into a nightmare. The 3-person crew, captain, first officer, and flight engineer, had no idea that a faint smell of burning wood detected 25,000 feet above the ground would soon become a race against time. What began as a quiet night flight ended with the aircraft engulfed in flames, its cargo and fuselage completely destroyed. The descent toward Philadelphia started normally. At 11:34 p.m., the cockpit voice recorder picked up the first officer asking if anyone else smelled something like wood burning. Moments later, the scent grew stronger. The flight engineer confirmed it wasn't electrical and no warning lights appeared, so the captain decided to continue. After all, strange odors weren't rare, especially when flying over forest fires or unusual cargo loads. But by the time the DC-8 dropped below 4,000 feet, the situation turned critical. The cargo smoke warning lights suddenly flashed, confirming their worst fear. The crew requested emergency services and began the cargo fire checklist, but smoke quickly filled the cockpit. Just 3 minutes before landing, black smoke was seen billowing from the cargo bay access panel. The crew donned oxygen masks, stayed composed, and landed safely on runway 27R at 11:59 p.m. The 3 men escaped down the forward slide with minor injuries, but the aircraft burned beyond repair. Investigators later traced the fire to cargo containers 12 to 14, though the exact ignition source was never identified. The National Transportation Safety Board concluded the tragedy could have been mitigated if cargo planes had onboard fire suppression systems, a safety feature still missing from several freighters at the time. What remained of UPS 1307 was a charred reminder that in aviation, even a faint smell can mean disaster. UPS Flight 6. On September 3, 2010, a Boeing 747-44AF N571UP operated by UPS took off from Dubai International Airport on a routine flight to Cologne, Germany. Just 22 minutes later, cruising at 32,000 feet, the crew reported a fire warning in the forward main deck. What began as a simple cargo haul quickly turned into one of the most harrowing airborne infernos in modern aviation. When Bahrain Air Traffic Control offered a diversion to Doha, just 100 miles away, the captain chose to return to Dubai. But within 3 minutes, thick black smoke invaded the cockpit. The fire control systems failed and the flight controls began to malfunction. The pilots were now flying blind. "Full of smoke, we can't see the radios," one of them transmitted desperately. The cockpit turned into a death trap. Toxic fumes filled the air, and 5 minutes and 30 seconds after the first alarm, the captain's oxygen system failed without warning, leaving him incapacitated. The first officer, now flying solo, couldn't see outside or even read the primary flight display. Communication with ground control had to be relayed through other aircraft because the smoke had rendered their own systems unusable. As the jet descended toward Dubai, it overshot the airport at 4,500 feet and 340 knots, unable to stabilize for landing. Controllers urged a diversion to Sharjah, just 10 miles away, but it was too late. The aircraft lost control and crashed 9 nautical miles southwest of Dubai, killing both crew members. Investigators found the blaze originated near cargo pallets 4 and 5, filled with lithium batteries and other flammable goods. The uncontained fire melted control cables, crippled oxygen systems, and filled the cockpit with toxic, blinding smoke. The disaster exposed fatal weaknesses in cargo fire detection and suppression systems, proving that in aviation, even a small spark can destroy a giant. UPS Flight 1354. In the early hours of August 14, 2013, UPS Flight 1354, an Airbus A300-600 N155UP, was moments away from landing at Birmingham Shuttlesworth International Airport in Alabama when everything went fatally wrong. The cargo jet, arriving from Louisville, Kentucky, was performing a non-precision approach to runway 18 because the longer and more advanced runway 06/24, equipped with a precision landing system, was temporarily closed. At 4:47 a.m., in darkness and low clouds, the aircraft struck trees and crashed short of the runway, killing both pilots and destroying the aircraft in a massive fireball. The crew faced a difficult situation from the start. Weather forecasts warned of low cloud ceilings and poor visibility. Yet the dispatcher never discussed these conditions or the limited runway options. During descent, the captain relied on a profile approach, using the aircraft's flight management computer for automated glide path control. But a small programming error, failing to delete an earlier flight leg, left a flight plan discontinuity that made the onboard glide path guidance completely meaningless. When the autopilot didn't capture the proper descent path, the captain switched to vertical speed mode, manually commanding a 1,500 feet per minute descent. Far too steep for a stabilized approach. Neither pilot realized that the plane was dropping below the safe altitude. By the time the enhanced ground proximity warning system shouted, "Sink rate!" too low terrain, the aircraft was already 250 feet above the ground and descending fast. Seconds later, the A300 tore through treetops and exploded. The National Transportation Safety Board determined that fatigue, poor coordination, and missed callouts led to the tragedy. The captain's decision-making was likely impaired by exhaustion, while the first officer, also fatigued, failed to announce the minimum altitudes. It was a chain of small human errors that ended in catastrophe, proving once again that, in aviation, precision and rest can mean the difference between landing safely and never landing at all. UPS Flight 916. On March 5, 2016, the usually quiet dawn at Albuquerque International Sunport turned tense when a UPS Boeing 767-34 AFER, tail number N305UP, came in from Louisville, Kentucky, and struck the runway tail first. The cargo jet, built in 1995 and powered by General Electric CF680C2B6F engines, carried 2 crew members, both unharmed, but the aircraft wasn't as lucky. The strike tore open a 23-foot section of its lower fuselage, damaging 4 fuselage stringers, 5 frames, and 3 floor stringers, along with the tail skid. The fix required a major repair, a costly reminder that even routine landings can unravel in seconds. The approach began by the book. The captain handled the controls while the first officer monitored instruments. Winds were strong, 20 knots, gusting up to 29, but visibility was clear. The jet descended smoothly on the ILS path for runway 03, fully configured at flaps 30, gear down, and holding 146 knots. At 1,103 feet above touchdown, the autopilot was disengaged, followed by the autothrottles at 158 feet, a risky deviation from UPS guidance, which recommends keeping them active until 50 feet. From that moment, things went sideways. The airspeed slipped to 128 knots. The pitch climbed to 8.4 degrees, and thrust remained too low. At just 800 feet from the threshold, the tail skid hit first, followed by the aft fuselage grinding into the runway. The pilots blamed a sudden 10-knot wind loss, but data told a sharper story. After a 1-year, 8-month investigation, the NTSB concluded that the captain's failure to maintain airspeed and pitch, along with the first officer's lack of monitoring, caused the accident. No lives were lost, but the event exposed how a brief lapse during final approach, mere seconds from landing, can cost millions in damage and reputation. UPS Flight 2918. In the early hours of January 10th, 2025, a UPS Boeing 767-34 AFER N324UP carrying cargo from Louisville, Kentucky, faced a tense mid-air challenge on approach to Southern California. Originally headed for Ontario International Airport, the crew encountered severe wind shear and, running low on fuel, diverted to San Bernardino International Airport. What followed was a nail-biting landing that pushed both the aircraft and its pilots to their limits. At 2:55 a.m., as the plane descended onto runway 6, the captain initiated a standard flare at 100 feet above ground level. But within seconds, everything changed. The aircraft's nose suddenly pitched up, and the sink rate increased sharply at just 15 feet. The touchdown was hard, registering a vertical acceleration of 2.2 g, and the lower fuselage scraped the runway, causing a tail strike. The pitch angle hit 8.1 degrees, enough for the tail to strike the surface despite no mechanical malfunction. An oral wind shear warning blared in the cockpit for 5 seconds, while the stabilizer trim malfunctioned immediately after impact. The pilots saw a tail skid warning flash across their systems, confirming their fears. Post-flight inspections revealed substantial structural damage: a crushed tail skid shock strut, damaged support assembly, and a bent jack screw actuator on the horizontal stabilizer. The NTSB later concluded the cause as an encounter with wind shear during landing, exacerbated by volatile gusts reaching 28 knots at San Bernardino. Miraculously, all 3 crew members survived, and the aircraft, built in 1998, was later repaired. For UPS Flight 2918, the night could have ended in disaster, but skill, quick decision-making, and resilience turned a near catastrophe into a lesson in precision flying. UPS Flight 2909. On October 29, 2024, a UPS Airbus A360-100 freighter, N162UP, was nearing the end of its overnight run from Ontario, California to Louisville, Kentucky, when a textbook landing turned into an expensive mistake. As Flight 2909 touched down on runway 17R, the plane's tail struck the runway, scraping metal across the surface. The crew sensed the impact, but continued rolling, unsure of the extent of the damage. Moments later, air traffic control confirmed their suspicion. The FAA classified the event as an accident, reporting no injuries but substantial damage to the airframe. Data later revealed what went wrong. After touchdown, the aircraft bounced, and the captain, already deploying the thrust reversers, eliminated any chance of a go-around. The nose pitched upward, reaching a dangerous 12-degree angle, forcing the tail into the runway. According to Airbus, pilots must keep the nose coming down smoothly after touchdown, but the combination of ground spoilers and reverse thrust created a perfect storm of physics that sent the rear fuselage scraping the asphalt. Inspections showed abrasion damage and broken fuselage frames. The NTSB concluded the cause was the pilot's incorrect pitch attitude during the bounce. The aircraft, built before A300 production ended, has remained grounded since October 2024 as Airbus fabricates replacement parts, a costly process for a freighter now valued at over $50 million. Insiders at Louisville's North Hangar say repairs are underway, with the jet expected to rejoin the fleet by peak 2025 season. Still, the event reignited debate among aviators about training lapses and tail strike prevention, with one veteran pilot remarking that selecting reverse thrust before a stable landing beggars belief. For UPS, it was a harsh reminder that even a minor misjudgment, just a few degrees too high, can leave a multi-million-dollar aircraft grounded for nearly a year. UPS Flight 109. The skies over Tokyo turned turbulent on May 6, 2023, when a UPS Boeing 747-400, registration N580UP, flying from Shanghai Pudong to Tokyo Narita, faced a sudden wall of wind that nearly slammed it into disaster. As the massive freighter descended toward runway 16L, wind shear, a violent shift in wind speed and direction, struck just seconds before touchdown. The pilots, executing a textbook wind shear recovery, fought to regain control, but the aircraft hit the runway hard at 10:52, the kind of impact that rattles even the most seasoned crew. Despite the jolt, the pilots managed to power up, climb back into the air, and circle around for another attempt. Roughly 20 minutes later, the aircraft touched down safely on runway 16R, this time without further incident. What seemed at first like a narrow escape would later reveal deeper scars. During inspection, engineers found the right inboard flap jammed against the aileron, along with deformations in the fuselage skin and the aft pressure bulkhead, damage extensive enough to ground the aircraft for 25 days in Tokyo. By May 31, 2023, Japan's Transport Safety Board (JTSB) had launched a formal investigation, noting that the full extent of the structural damage wasn't discovered until May 26. The winds at Narita that day were so erratic that a wind shear warning had already been active for runway 16L, underscoring how close the cargo giant came to catastrophe. Even a jet built for endurance and flying under one of the world's largest delivery networks can find itself humbled by nature's unseen forces. The ongoing investigation aims to uncover how a momentary wind shift nearly tore apart a 747 weighing over 800,000 pounds, reminding aviation that control is never absolute, especially when the wind decides otherwise. USPS Flight 2559. On April 24, 2000, USPS Flight 2559, a Boeing 727-151C operated by Emory Worldwide, became one of California's most haunting aviation disasters, at least in the virtual world. The cargo flight, carrying 3 crew members and a mix of federal documents, electronics, and parcels from companies like FedEx and Amazon, was en route from Las Vegas to San Francisco when disaster struck. At 24,500 feet, a cargo pallet erupted in flames after the battery of an Apple iBook G3 clamshell exploded midair. Within seconds, the aircraft was engulfed in smoke, forcing the crew to declare an emergency and divert toward Fresno Yosemite Airport. The explosion shredded hydraulic lines and crippled flight controls. As systems failed one by one, engine number 3 ingested shrapnel, and engine number 2 later died mid-descent. The pilots battled to control the aircraft using uneven thrust, a desperate dance with physics. At 9:48 a.m., Flight 2559 slammed onto runway 29R, bounced 4 feet into the air, and exploded 16 seconds later while still moving at 103 knots. 2 crew members died instantly. The 49-year-old captain, Benneth Shinkawa, escaped through the flames, suffering multiple fractures but surviving. The NTSB blamed battery overheating and mishandling at Tucson Airport, while conspiracy theorists claimed it was a terrorist bombing, citing the classified government cargo on board. It remains listed as the deadliest cargo crash in California's history and one of the largest federal document losses outside of 9/11. Following the incident, aviation authorities began mandating stricter lithium battery shipping protocols, reshaping how electronics travel in air freight. In later years, Flight 2559 inspired the 2005 thriller Flight 883 and an episode of air crash investigation titled Fiery Landing, where the real surviving captain recounted the harrowing descent that turned an ordinary mail run into an inferno in the sky.